Hey, my student friends, welcome back to the fifth session. We are actually learning on the DBMS technology. We covered kind of chapter 1 in the last series, the last four sessions. And building on the same, we'll be now looking at the chapter 2, and we'll be specifically looking at what is entity relationship model, what are the concepts behind it, and we'll be actually doing this also in couple of more videos. So today is probably a short 10-12 minutes video where we are just introducing the concept of entity relationship model. So we did talk about it last time. Before proceeding further, let's do a recap of what we looked at in the last four sessions, or maybe in the last four chapters. Last one chapter. So we looked at we started with something called as what is data. Then we defined what is database. Then we looked at the definition of what is database management system. That's where the DBMS word is actually originated from. We talked about a few personalities who felt the need of introducing this kind of a software database system. Then we kind of looked upon the various data models. So obviously when you're storing your data into a database, not into file system but into a DBMS system, you need to follow some techniques to store that data using something called as data modeling. And then there are various data models available that we talked about, like hierarchical network, entity relationship, and relational. So entity relationship is what is the topic of today's talk. DBMS structure we talked about. We talked about what is DDL, like data definition language, data manipulation language, what is data dictionary. So based on this, we'll further now move on to what is entity relationship diagrams, or what is it really mean by entity relationship. So let's look at the concept of database design, right? What it really means. So now when we say we have a database and we store the data, now how do you store the data in the database? It's not like an Excel file or a text file, right, where you just dump the data there. Then what you need to do is you need to actually define the right set of data model based on the data that you have. And then you actually follow a particular process methodology, which is using the data models that we discussed in the earlier chapters, earlier session. And all those data models, you may be selecting one of them suitable to your database, and then you actually do a design of your database to store your data. So that's whole process is called as a database design process. So technically speaking, it's a process of producing a detailed data model of a database. Now what is data model, that we will definitely look at, but the process of actually creating a detailed data model for a database is a database design. Now what you do is you actually create something called as a logical data model, which is kind of all the logical and physical design, and the choice of how do you want to store your data and the parameters is actually defined in the logical data model. And then when you actually generate that design into something called as a query language, or a SQL, that actually is called as a data definition language. And then that DDL statements, or whatever DDL script that is being generated, can be used to create your database. So that's the overall database design overview. And actually you actually create a data model with all the attributes to your entities, and we obviously look at what is entity, what is attribute, and all these things as for our ER model. But when you create a fully attributed data model that contains detailed attributes for each entity in your database design process. So logical data model, like let's say if I am designing a system where I need a student information to be stored. So obviously just few attributes of student could be he has a roll number, he has a name, he has a photo, and then I also define that the roll number will be always a number, name is actually a string, and then photo I am going to store, which is going to be image type. So this is your logical data model where you are telling what are the attributes, and then you are also telling what are the storage parameters that I'm going to use. There could be another entity no, which is like courses, because the student will be appearing for the courses, and there that attribute courses attribute could be course number, course name, etc. Right, and then these two can be combined, wherein one student probably appearing for different courses. So that could be a student courses entity where we are telling that this roll number is appearing for these multiple courses. So that's if you look at the last diagram, right, it is actually like I have an entity called student, I have an entity called courses, and I have an entity called student courses, and there is a relationship between the student courses and stud courses. So the roll number in the stud courses is coming from the student entity, and the course number is coming from the courses entity. So that's where we come, where there is something called as entity relationship diagram. So what is that called actually? So database design is actually represented and documented using those ER diagrams. So right, we just are looking right now as an example with 2 or 3 entities, but when you actually create a practical application, let's say banking application, there could be probably at least few hundreds of entities, and you can't memorize it, and you can't really know what is the relationship between these two, between these hundreds of entities together, unless you document as a ER diagram. So that's where entity relationship diagrams are very important. They show the relationship between data and entities that we talked about. So the main data objects for are inside the entity relationship diagram are entity, entity set, and attributes. So what is entity? We already looked at, right? It's actually a real world object, like we talked about student, right? And it holds the relationship between like a student and course. So that becomes a relationship between two different entities. And then there is something called as entity set, right? If a student is an entity, all the students data in entity in that entity is actually becomes an entity set. So one student is one entity, but if there are like 100 students in the college, right, or in a class, that becomes your entity set. And attributes, of course, we talked about, right? The roll number and the name and the age and things like that. So it is represented by each entity will always be represented by its a set of attributes, right? And they are actually characteristics of that entity with relevant information about that particular that object. So relevant information of student, like what is his roll number, what is his name, what is his age, what is his birth date, and things like that. So this is just an example, right? Employee has an employee number, that's an attribute of employee entity. It could have a first name, and it could have a last name, it could have a date of birth, and it could have a city and things like that. So when you say attribute, right, and again the attribute could be of different types, multiple types. There could be something called as a simple attribute, composite attribute, single valued attribute, multi-valued attribute, stored attribute versus derived attribute. So there could be stored attribute, attribute could be called as a stored attribute or a derived attribute. We'll look at that what it is, and then there could be a null attribute. So let's look at simple and composite. I'm going to take two together because they actually somehow relate to each other, so that we can well define the difference between them and understand what it really means by simple and composite attribute. So simple attribute is actually something like they call it as atomic attribute because it's just a single value, right? And they cannot be divided into multiple smaller subparts. So for example, employee number, it's always going to be one single value. So that's a simple attribute. Or a designation of a person. A person in a company cannot have multiple designations, so won't have multiple. So that's a single attribute value, right? Then attribute is represented graphically by this kind of ellipse, right? If you see, I have a ellipse there and I'm saying employee underscore number, that's an attribute of my employee entity. And if you go and look at what is composite attribute, it's little different than single simple attribute. it can be divided actually into smaller subparts, and meaning that more basic attributes with independent meanings. So for example, let's say you have an address of a person, right? This address could have a part called street address, city, state, and zip. So that actually becomes the composite attributes, because I can actually distribute the address into multiple subparts: street address, city, state, and zip. So that's the simple and a composite attribute. Now there could be a single valued attribute and there could be a multi-valued attribute. So single valued attribute, what is it? Employee number, we said, employee age, right? It could be only one value to one entity. Multi-valued, it could be multiple values to the same attribute. So for example, a phone number of a person could be multiple phone numbers, right? I can have two mobiles, maybe one landline, and things like that. So that becomes my multi-valued attribute, and the name itself denote, right, what is multi-valued, because it has a multi-value. Then there could be, let's say for example, degrees for one person could be multiple, and this is how you actually denote a multi-bit attribute, like with two solid ellipses. then we said about there is something called as a stored attribute and derived attribute. Stored attribute is nothing but it is not dependent on any other attribute. It is directly stored in your data or in your database. But a derived attribute actually will depend on some already stored attribute. So for example, right, you tell you will store the percentage of a student into a database, right? But you can derive something called as grade from the percentage of marks. So you will always see, like, in your mark sheet, like 0 to 35% is fail, 36 to 60% is pass, something like that. So that's where the total percentage now becomes a stored attribute, but what I can derive out of it is called as a grade attribute. So that's where stored attribute and derived attributes come from. So this is the stored attribute and this is the derived attribute. How do you now represent the derived attribute? Is with this kind of a eclipse, dotted kind of an eclipse, concentric eclipse called. Now we said entity, and then there is something called as entity sets in the ER diagrams, right? Entity sets. So when you actually have multiple students, right, that becomes your entity sets, which has like same set of attributes. One student will, multiple students will always have their roll number, their name, their age, their birth date, and things like that. So that whole student data becomes the entity set, student entity set. And then each entity always has a key, and each attribute has domain, so that is called as a value set. So for example, employee roll number becomes, there is something called as a primary key. We'll see primary key at later stage, but let's, for this sake of understanding, primary key is nothing but is used to uniquely identify your entity. So a student will always be uniquely identified with something called as a roll number, because there could be two students with name, let's say Virendra Wadekar, but the roll number will be always different. So that's called as a key. Here it is called as a primary key. Right? Entity has sufficient attributes to form primary key is called a strong entity set, right? So that entity is where there is a possibility of defining primary key, that becomes a strong entity set. And there is something called as a weak entity set, right, where you don't have a key attribute, and all the weak entities will actually always depend on the strong entity. So there will be like owner-child relationship kind of, or parent-child kind of a relationship, where the weak entity will be, there could be multiple weak entities which will be always depending on a strong entity. The owner entity set and weak entity set must participate in one-to-many relationship. So for example, there could be one parent and multiple childs, and there could be many weak entities. So we'll see what is all these one-to-many, one-to-one, and all things like that later point of time, right? So weak entity set must have total participation in this identifying relationship set. So let's look at what it really means. So strong entity is customer, right? Why strong? Because I can always identify a customer with a customer ID, and this could be attributes of my strong entity, like cust ID, name, address. Now this customer, let's say being a bank customer, what he can do is he can always borrow a loan from the bank, right? So borrows is a process and is borrowing a loan. Now the same customer can actually borrow multiple loans, right? So that becomes many loans for one customer. But now the loan won't exist as on its own, right? I won't know whose loan is it unless I know the customer. So that's where this is called customer called a strong entity, and loan becomes your weak entity. And the strong entity will be identified by the primary key, whereas the weak entity will have a composite definition of the loan number plus the customer number. That is what is going to tell me the identity of the loan entity. So that's how you kind of define the strong entity and weak entity. So weak entity set is the one that depends on its owner entity. That is the strong entity. We talked about the customer and the loan, right? Weak entity is denoted by the double rectangle that we looked at in the last slide. Weak entity do not have the primary key. Instead it has a partial key that uniquely discriminates the weak entity. So as I mentioned, right, the loan number can't exist on its own. It has to be identified using the customer number, like which customer ID has which loan number. So that's where this partial key of uniquely discriminating the weak entity comes in picture. The collection of similar weak entities is called as a weak entity set. So loan kind might have multiple loans. That becomes your weak entity set. The relationship between a weak entity and a strong entity is always denoted by an identifying relationship. That is the double diamond that we looked at in the last slide. Right. So let's move ahead, and these are the differences between your strong versus weak entity. We talked about it. Strong entity will always have primary key. Weak entity actually has something called as a partial discriminator key that we talked about with example. Then strong entity is independent of any other entity in your whole design, in your whole schema, whereas weak entity always depends on the strong entity, like loan always will be dependent on customer. Strong entity is denoted by a single rectangle, and this we talked about, it's going to be double rectangle. Strong entities relationship, like the relation between two strong entities, is denoted by a single diamond, whereas the relationship between weak and a strong entity is denoted by a double diamond, which is called as an identifying relationship. Strong entity may or may not have total participation in the relationship, but weak entity always has total participation in the identifying relationship shown by the double line. So that these are the differences between strong and weak entity. So what is relationship? Relationship is association among entities. So we talked about it in the previous slide, like student has a relationship with the course. Entities are connected by relationships. So all the entities in your entity relationship diagrams are connected by relationships. This is the third aspect of your entity relationship diagram. Relationship represent a set of connections between entities. So that's the definition of relationship. Degree of relationship is the number of participating entity types, and relationship among two entities is known as a binary relationship. So this is what is a relationship. Customer purchases atom, right? So that's a relationship between a customer entity and an atom entity. So continuing on the same, there could be multiple types of relationship: one-to-one relationship, one-to-many relationship. So one-to-one is like country has capital, because the country will always have one capital. So there is relationship like one country has one capital. One to many, now one customer can purchase multiple atoms, right? So there is only one customer purchasing multiple atoms. That becomes one to many relationship. Many to many relationship, like I own a company and I have all subsidiary companies, so multiple companies of mine can have multiple suppliers supplying to those companies. So that becomes many to many relationship. So that's all. Until now we talked about relationships. So we talked about what entity relationship model is. Now we'll further in the next session build on all this discussion that we did, and we'll actually go into the database design stuff. Thank you so much for watching the video. Keep watching and please subscribe to the channel, and you will be getting very frequent videos on these DBMS topics that we are discussing. Thank you so much. Bye.